So today we're going to look at arithmetic sequences in series. And CJ, I don't think that she can hear you at least very well. Hello, Esther. The class says hello. Okay, maybe you heard some mumbling there. So, arithmetic sequences in series means that we're taking and we're starting at some beginning term, such as 4 in this case, and we're adding something each time. So in this one, we can see that we're adding 3 each time to get to the next term. So plus 3 gives us the 7, plus 3 again, the 10, and plus 3 for the 13, and we can continue that on infinitely. Yes, David? Because my microphone is hooked to the computer. That's the way that that's working. Okay. So we want to determine the common difference. Well, common difference would imply we're subtracting. So common difference, we're just always going to take one term minus the previous term. In our first example here, we see we take 7 minus 4, gives us a common difference of 3. So 3 is what was being added each time. So this next example, the common difference, if we take negative 36 minus negative 53, we get 17. So we see that we're adding 17 each time. So plus another 17 would give us a 2 here, and then 19, and 30, 36. I did it wrong last time, didn't I? Am I adding right? I'm having trouble with my addition. Is that what you're saying? So if we add 20 and then subtract 3 is the easy way to do it? Oh, negative 2. There's the problem. Oh, thank you. Okay. So negative 2 plus 17 is 15, plus 17 is 32, plus 17 is 49. So there's the next terms. Okay, so as we mentioned yesterday, we can look at these either recursively or explicitly. And so recursively means that we need to know the previous term to find the term that we want. So recursively, we can find that by adding the common difference to the previous term. So that's our formula here. A sub n equals a sub n minus 1 plus d, the common difference. So we see for the previous one, we had a negative 19. So if we want the term after that, we take, that would be a sub 4 is equal to negative 19 plus d, which was 17, not 8. Gave us the negative 2, and so on. So each time we take that, and that's a recursive formula. An explicit formula gives you any term in the sequence that you want without finding all of the others. So based on the number of the term. So here we have the formula for an explicit formula for an arithmetic sequence. We can always find the nth term by taking the first term, a1, plus n minus 1 times the common difference. So think about what's happening as you go through this. If you start with the first term, the first time you're adding the common difference 1 time. For the third term, you're adding the common difference 2 times. And then adding it 3 times. So the n minus 1 is how many times d is getting added on. So we can find, as in this example, the 15th term of an arithmetic sequence with the first term 4, common difference 6. So we want a sub 15. So that's a1, which is 4, plus n minus 1. So 15 minus 1 times d, which is 6. So 4 plus, let's see, 14 times 6 would be 84. Very good. So we know the 15th term would be 88. And we didn't have to find the second term, the third term, the fourth term, all the way up to the 14th to be able to get term number 15. Okay, so that's a very important formula. A sub n equals a1 plus n minus 1 d. We want to find a recursive and an explicit formula for this sequence. So first we would check out and find what the common difference is. So that is negative 11, because if we take the second term, 3, minus the first term, 14, gives us the common difference. So negative 11 is the common difference. And so the recursive formula is a sub n equals a sub n minus 1 plus d, which is negative 11. And of course, we could put minus 11 there. There's the recursive formula. For the explicit formula, we want a sub n equals a1 plus n minus 1 times d, which is the negative 11. So for that particular sequence, there's the recursive formula and the explicit formula.